Very good morning to all the students. This is Sayyid Usman Ahmed, and I'm recording this session for all those who have missed the Unit 1 part. And this is something like it's a refresher course for those who actually want to revise what was there in Software Engineering Unit 1. So let us start with the basics of software engineering. Software engineering is the establishment and use of sound engineering principles in order to obtain economical software that is reliable and works efficiently on real machines. This is one of the definitions, but what we actually, when we ask, we define software engineering, we are looking for an IEEE based definitions which we have already seen in our previous in the classroom lectures. This is when we say what you understand by software engineering. Okay, so you can write this definition. When we ask you what do you understand by software engineering, you can establish that software engineering is the establishment and use of sound engineering principles. So there are certain engineering principles based on which the generation of software takes place, or the development of software take place. So it's very approach is very engineering based approach, because there are some principles, there are some quantifiable inputs, there's a systematic approach that is being followed, and that creates a more reliable and efficient software that actually works in real life scenarios or real life machines. So any engineering approach must rest on the organizational commitment to quality. That means that all the engineering work that we do today rest on one fundamental notion, that is commitment to the quality. So if the thing is, if you don't have a sound quality based product, the product will never be scaled or never be marketed in the society or in the audience, because of which the product may fail. Okay, it not get its worth value. So this thing tells us that the base of all the development that is done in a software is the quality. So based on this, we can draw uh, how we can maintain this quality. We can maintain this quality uh, using uh, two approaches. One is called uh, total quality management and Six Sigma approach. Okay. TQM is a concept in for quality management. It says that it will ensure that all the product that is delivered, all the work product that is created, will be of a certain quality standard. Okay, it will try to achieve those quality standards that have been set by the customer or by the company itself, to make sure that the product, when rendered to the customer, is of certain set of quality, right? And it will not deteriorate any of the work products below the quality. But Six Sigma approach rest, we have some more options to enhance the quality in each of the iterations that is taking place. So if one set of quality like work product has been delivered, the next thing will be to monitor or to improve the issues or minor issues or major issues with that particular release. And in the next release, you are going to have a better solution for the product itself. So with each iterations or with each level of increment, you are getting more and more quality. You are going to more and more idealistic product. Okay. So there are six stages of Six Sigma. One is called the define stage, that gathers the requirement, that reads the requirements and clearly and elaborate them, illustrate them. These are one of the stages. Then the second comes, what is the critical the measure of the requirement? How much planning is required? What is the resources it's required in that particular to implement the requirements? So this is the second stage. Third is now analyze the problem. What is the problem that you're going to solve? You combine multiple requirements in one set and then see that if we can resolve this issue or not. And you then change the algorithm and then check whether you are going to have a better output or not. This is called the analysis of that particular problem. Then once you analyze the problem and you start working, then you have to find certain root causes. The root causes generally is a particular term that is used in many industries, but in software we want the same reference, that if you want to remove the cause, you need to fix the root first. Okay, suppose in this, if I say that there is a code here, and this is a module which is having issue, and module 1, 2 and 3 are the module that has been calling this module. So if a tester finds an issue in module 1, I can fix it in module 1. Okay, and the module 1 will work. Okay. Now the thing is, this module 1 will work, but module 2 and 3 still will have the problem. Okay. So there might be n number of modules which will be calling this. The problem was with module 1 itself. So I need to fix this module 1 before I go and fix 1, 2 and 3. If I fix this and then I fix 1, 2, 3, next, and any module that has been created using this hierarchy will never have the issue. So this is called the root cause mitigation issue. Finally, there is a control stage where I sustain the improvement. That means whatever improvement I do, I will just check whether the improvement is sustainable or not, and it should retain itself. Okay. The foundation of software engineering is the process layer. So you should have a very, very sound process. If your process is good, the outcome will be good. This is what we actually see when we go in a market to buy a product, say a fabric. We will look for a branded fabric. Why? Because we believe that the process through which the fabric is made is had a certain process. It goes through certain stages, and stages ensures us that the quality will be good itself. Okay, so the process is good. The process defines a framework that must be established for effective delivery of software engineering technologies, and we the process management or the process evaluation is done through CMMI, that's capability, maturity, model integration. This is a stages based system where it ensures that more the higher number you are at, your company is at, the company is following a more stringent process. Okay. If CMA level 5 companies like Infosys, IBM, Accenture, TCS, these are the companies that are CMA level 5. They actually have lots of process. You cannot change a single piece of code without following a particular process. You have, if you get an issue, you have to log it. You have to tell the team that this is how I did it. You have to mitigate the issues. Everything in every stage that you work in will require a certain set of processes. So, to sum up, the importance of software process forms the basis of management control of software projects. That means how you are going to manage the projects, and how you're going to manage the changes that are happening in the project continuously. Okay, so lots of people working on different projects, maybe on the same set of code. You want to make sure that they do not overwrite the code. They should not touch somebody else's code, or there should be a proper standard that will be followed when they are saving the code, something more of the sorts. It establishes the context in which the technical methods are applied. So, what is the context level is defined. It takes care of the work products that are generated. So each stage of software engineering generates certain work products, like requirement generates SRS, design generates SDD, and test plans, maybe documents, maybe models, maybe data. All them are being defined by the process itself. Which stage will define what is defined by the process, and establishes a milestones, ensures quality and manage changes in the controlled way. So you all have to do this with a set of processes only. So we need to have a very sound process if we want to achieve the base of the layered approach, which is called quality. So this is the final layered approach. It says that I need to focus on the quality. If I have the quality in place, the principles in place, then I need rest on the process. Okay. So this process ensures that the quality will be taken care of. You are not going to have a compromise on the quality if you have a very sound process. So to implement this process, I need certain methods, okay, and that some algorithms, some operations I need to create how to ensure that things will happen as per the process. Okay, now to implement these methods, I need some help from a technical system, that is tools required, and these tools will implement these methods. So this is a layered approach, and we will go on forward from this point and study more about software engineering process models in our next lecture. Thank you.